All right. Thank you very much for coming. My name is Will Florentino. I'm from Renesas. I'm in the industrial business group. I'm one of counterparts around the world from our Europe team, Japan teams, and Asia Pac. So I manage the Americas side. So hopefully today I'll give you a little bit of background of what industrial IoT really means, not just adding an I to the IoT. We always add, as long as you have the IoT buzzword, then all of a sudden it becomes relevant, right? So, but we want to be able to provide a little bit more context and background. So obviously a lot of the OEM companies like the Siemens, the Schneiders, the Rockwells of the world are really gearing towards this next generation, leveraging the IoT for their sake. So what I'll talk about today is just some of those components. What makes IIoT a little bit different? What are the components of an IIoT solution? And we'll walk through some of those elements that we have as Renesas to provide customers like yourselves, integrators, the developers, and things like that. Okay, so I've been at Renesas about 3 years. I worked for Xilinx and Altera, both in the industrial business unit. I've been in the single board computer networking for the past 15 years, or I guess 18 years. So some experience on industrial. Okay, so you've seen this slide a lot. This is the general platform slide. I think we're actually going to be talking about all three of those, from the devices, the platforms, and the solutions. So hopefully you'll get a picture of what we can contribute to the industrial IoT space for your solutions. So again, I talked a little bit about what we were going to talk about, and hopefully some of the good takeaways that you have. Okay, let's just get started. So first thing that industrial IoT changed that is different is that in the typical IoT world, the cell phone, the mobile phone, obviously that's been the center of everything. Being able to access data, being able to get the visibility, all within your cell phone. Unfortunately, in industrial, that is not the center. The center is the operations, the process, the machines. That is the center of industrial IoT. Now, all the other pieces you might be familiar with: security, connection, safety. All these pieces are common to different verticals, but it's implemented a little bit differently, and I'll walk you through some of that. Another misnomer was M2M. So, if you're as old as me, 15 years ago, M2M was driven out of the cellular companies, right? So cellular guys said, I ran out of people, so I'm going to start selling my modules to machines, and hopefully the machines start talking to each other. Unfortunately, the cellular modems were not able to get into below the control level. The reason is because there's a lot of different components: real-time, security, the fast connections, and the redundancy that's needed. So what happened in the old M2M world was that it was good for asset management, perfect. Things that are moving around, things that are you're tracking, trucks, things like this, that's where the old M2M is. The new M2M, and that's, it's being redefined, right, in IIoT M2M, is now the secure, more global connection, global access to the data, and it doesn't really matter whether it's in the cell phone or not. So that's the new M2M. So everyone has seen this chart, maybe. GE calls it the third wave. Siemens calls it the fourth industrial revolution. As you know, everything around industrial revolutions are pieces of technology that was used to improve production. It was able to reduce failures. It was able to improve the quality of the product. So as an example, the powered loom was started in the 1800s. Then you've got the assembly line. You're able to do some repetitive production. You're able to provide more quality and be able to understand what are those common components so you can reduce your production. And then the invention of the PLCs, the programmable controllers. So these are where the first relay ladder logic kind of operations and solutions, but then a lot more electronics came in. Obviously, the internet came in. And the way the factory used the internet was really more about just using the cable. So if you're familiar with the protocols like EtherCAT or Profinet or Ethernet IP, these are driven out of the industrial OEMs. What did they do? They actually just used the wire but they defined their own protocol. They made their own Mac, the custom Mac. They put it in an FPGA. They've made it in an ASIC. So all of these different protocols, and that's how they communicated with one another. The fourth industrial revolution, what I call is the perfect storm. There wasn't any major discovery of a whole new world of technology. It was this combination of things. So first is that the plants, the factories themselves became more focused on sustainability, improvement of usage of resources, as well as being able to understand, how to collaborate with one another in different sites and locations. So they became more green. They were focused on sustainability and using their resources. Another technology trend was the robotic side, not just in the sensors and technologies, but also in the robotics. So if you heard of something called collaborative robots, and collaborative robots are those robots that sit beside a person that's in the production floor that does the redundant motion, so that the person could provide a little bit more intelligent work instead of wasting time carrying stuff and putting things. So you see a lot of those examples where there's these bins of robots that go past from within the factory floor, just distributing parts, spare parts for the guys to put it together and stuff like that. So all of these this combination of the robotics and sensors technology are adding to the whole industrial IoT success. Everybody knows cloud computing. And the cloud computing is not about just being able to say, yes, we've got this big giant data in the cloud. It's being able to leverage some analytics, being able to leverage some intelligence, not just on the data, but also to be able to provide maybe some security context as well, and and again, the objective is to reduce operational costs. We talk about security, and of course, it's a big word, big bad word, security. There are different kinds of security. We'll talk a little bit about security in the network, as well as security at the device level. Because it's also very important at the factory. Next one is profits. Obviously, in any operation, you're not going to do anything. The factory's not going to do anything until they can prove ROI. It's not about a buzz. It's not about being fancy in the technology. They want to create new business or improve their ROI. For the industrial OEMs, they're looking at this as a new business opportunity. There's a lot of new opportunities that instead of just selling boxes, they're actually selling services. I went to a show, the ARC Advisory Forum. I don't know if a few of you come. I went to a Schneider booth, a Rockwell booth, a Siemens booth, and none of them had a PLC in their box. What were they selling? Virtual manufacturing, cloud connection, monitoring of your assets. Those are what they were selling. So if you can imagine, these guys are looking at new business streams, and this is a good opportunity for you guys in the systems integration world or in your own devices or in your own companies to add that as part of your profitability. I know that people are not here just to do the buzz. So let's just imagine what industrial IoT is for just the airlines. So this is a GE picture, and then they always say that 10% of unplanned or unscheduled delays is based on unplanned downtime, maintenance issues, right? So, and that costs about $8 billion in additional costs. So imagine there's 60,000 flights here in the US, 10% of that is delayed just because of that unplanned maintenance issues. What if the airplane, before it even lands, understands that it needs some maintenance beforehand? It needs the right personnel to be called. It needs the right parts to be put in so that you can do the maintenance even prior. What if the engine manufacturer gets the data of the efficiency of the engine right in real time and makes some real-time analytics and understands to tell the engine manufacturer or the airplane company to say, oh, let's tweak the turbine settings and configurations a little bit differently. Or an HVAC guy who's controlling the airplane's HVAC saying, well, you know what, it's time to replace my air filter. And there's a guy coming in before the airplane lands. He knows the right part. He gets the right service person, and he's already there. So with that savings of just reduced timing for any kind of maintenance is a big deal for the airlines. Let's imagine what it is for the factory. So first is censored-enabled automation. So what does that mean? It means that you're adding more sensors to the machine, not just to look at throughput or the quality of the product that you're producing, but also the condition of the machine itself, the temperature of the motor, the condition of the inverter that's inside. All of these things are going to be needed as part of this industrial IoT. More sensors inside the machine themselves, along with the plant itself. Another piece is real-time analytics. So obviously, everyone's understood what analytics is. Real-time is a bad word in industrial because it means different things, right? So you can do real-time in milliseconds. You can do real-time in microseconds. You can do real-time, or just making sure that it's in 1 second, but it's deterministic. So there's different realms of what real-time really means. So I'm not talking about real-time being the fastest you can get it. I'm talking about real-time to the point of the time that you need it, the time that makes it relevant for you. And then you adjust to what is needed for your operation. Another part is called virtual manufacturing. Virtual manufacturing, in GE they call it the digital twin. In Siemens they call it virtual manufacturing. What they do is they make a virtual copy of the plant. Let's say it's an oil and gas plant or a nuclear power plant. And they do this digital twin so that they can tweak their settings. Let's say, for example, they understand where the hot spots are, the microclimates within their factory. Where is it hot, right? They're able to get that because they're sensing the data from the real valves and sticking it in their virtual twin. And the other thing is that they can make changes to their settings. So let's just say, you know what, I'll change the valve, make it a little colder over here. I'll put a little bit more gas in this operation, or a little bit more components in the machine. So those types of things that you can do in a virtual twin. I saw an example of it that they said, you know what, I want to put a machine plop in the middle of their factory floor. Because they had the digital twin, they knew exactly how they would move the machine to get into the small spaces of the factory before they even did it. So that actually saved them a lot. The fourth one, you'll see this from the Siemens a lot, is cyberphysical systems. So cyberphysical systems is a very big word. It just means that they were able to incorporate a process as autonomously as possible. The machine becomes more context aware. It understands the other machines, not just what it's doing, but the machines A, B, and C, what they're doing, and saying, am I optimized for what A, B, and C machines A and B are doing? So if you're able to do that, then you can actually have an autonomous factory. It could be self-aware. It could be autonomous. It could actually do the products. And you can customize it as well. Just imagine if you want one widget from one company, and they say, okay, give me a lot size of 100, and this one is another lot size of 100, but it's changed a little bit. The factory can self-adjust. That's the magic. That's the holy grail of virtual manufacturing, of the cyber-physical systems. So the economic impact of IIoT is about 1.2 trillion. So if you're in the business of industrial and you have these opportunities, definitely it's a good time to be in IIoT and understanding where the values are. So what's happening is the industry is mobilizing. They're trying to figure out. The study was that more companies that are building machines are actually going into more service, service business. And so this customer relationship model is what people are thinking, oh, you know what, I used to sell boxes, now I can sell services. And that's more sustainable, that's a higher profitability for the company. So what's been happening in the industry is consortiums, right? You see consortiums popping out all around the place. So you've seen industrial internet consortia, partners that didn't used to be partners in the past, where you got GE, IBM, AT&T. They were now a consortia partner. They're defining the next generation industrial internet reference architecture from the safety side, from the networking side, from the analytics side. They're all wanting to define what that is. You've seen other alliances, the 1M2M, Allseen, all of these are all consortia of companies trying to figure out who they want to play with. So And of course, Industry 4.0 is driven by the German government, right? So everyone in Germany, it's endorsed by the German government. They're focused on the operation of the plant, making sure that do we have the right standards of communication within the factory itself. So I think the message that I wanted to show is make sure you've got a partner, a strategic partner, because you can't do it all. You can't have all the technologies. You can't have all the security and the connections and all that stuff. Make sure you play with the right partners. Make sure it's a win-win for both of you and or within the consortia. And see if you can influence as much as you can within the technologies that are coming up to leverage some of your core competencies as well. So let me give you a couple of examples of this new trend of software and services. So just these 3 examples from Schneider, Rockwell, and GE. So Schneider, they create this dashboard. They call it the system monitor. A resource advisor that they call. So they're able to, based on their PLCs, they're able to extract that data and give the data to the end user of that machine or the factory. So with that software, they're able to virtualize, provide some data points where it is in the factory, where is the production, in what location. Rockwell, on the other hand, has a different approach. So 2 approaches. One is they worked with Microsoft Azure to use that same web factory. Again, it's visualization of the data and stuff. But they also worked with Cisco. So Cisco and Rockwell had a joint solution to do a hardened switch for industrial. So that they could say that, hey, Cisco owns all the routers from the IT side. If we can create a switch inside the factory that is Cisco compliant, then we're good to go. So that's one of the things that Rockwell did. For GE, they created a whole new software platform, what they call, again, the bad word of platform, but it's a buzzword. But it's a cloud-based platform so that they could have many partners associated in providing analytics. They would be providing some intelligence. They would provide predictive maintenance modules, these types of things. The problem with their solution, or at least one of the elements of their solution, is they have to sell you their field agent. So this field agent plops into your plant, they drop it in. You can bring in all the data that you want into their field agent. I think they do about 1,000 data points in their field agent. But of course, it's a product as a service. They sell you the box. It's about $100 a month that you can use a box, plus the data that you're streaming. Then, of course, because the modules that they have from a software perspective, that's where they also make money out of that. And of course, it doesn't hurt that you're buying some of their PLCs as well, right? So, again, these guys, the big OEMs, are trying to understand how they can play in the industrial IoT space. And they're looking at these different business models. So you should look at these as well. Take advantage of how these guys are looking at it and understand where can you fit in these different realms, or within your own application space. Everybody wants to verticalize their own cloud and everything. I think it's not, from an industrial IoT perspective, I don't think it's that efficient to be just vertically owned. You want to own vertical everything. So obviously, in terms of challenges to adoption, the first is even the terminology. IIoT, Industry 4.0, autonomous M2M, all of these terminologies are being used by the industry, and each one of them, they tweak their definition of it. But at the end of the day, it's about reducing wastage, improving throughput, being able to provide visibility and analytics and intelligence to the data, to the machines. The other issue is interoperability and standards. Like the Industry 4.0 guys are looking at different standards to that security and database modeling and how you're managing data, where the other groups are not as focused on it. So if you're in the industrial Ethernet world, then you know that industrial Ethernet was all over the place, a lot of different protocols. But again, it's that interoperability that's going to be the challenge. The others are soft challenges, but real challenges. The other, it's business justification and education. So there really is a clear I mean, for us, doing the story, doing the buzz, it's fine. There's a business justification, right? But at the end of the day, the guy who's the plant manager, the plant owner, has to really justify changing all of his networking. He's going to go through, he's going to start making his machines visible in the cloud without security, and not understanding all of these components, right? So I think that's going to be a big challenge for anybody who's in the plant, the plant owner, the plant manager. So that's going to, they have to justify, obviously, the cost of implementation. Another thing that's really different is this expertise gaps. So the expertise gap, it's now a combination of IT and OT. In one of the sessions, they said the CIO is now the king of the factory. Why is that? Because they're thinking that, fine, you can get the data out of your machines, but the CIO knows what to do with it, and they know how to give it to management, right? And or their other players. So being the CIO has now become an integral part of the factory operation. So it's this IT OT discussion. So I'm a factory guy, or an industrial guy. When I meet with an IT guy, I don't know what he's talking about modeling databases and things like that. So it's a whole different terminology. And when they talk about gateway or edge device, they say, oh yeah, the edge device is the controller, and you're good. We're the edge. But what is the edge for us, right? The edge is the sensors, the machine itself, the things that are below the controller. That's what the edge really is. So so the main components, I showed it to you earlier. One is connected. Obviously, the center was what I mentioned, operation of people, services, the processes and control. When I said connected, the reason why I didn't say cloud, fancy word or whatever, is because there's so many different time domains within the factory itself. I just say connected because it requires this intermodal time zones, time domains, that it has to communicate seamlessly. So that's one of the big things. So if let's say you say, oh wait, let me make a sensor, and I'm going to plop it in the factory. If you're not tied into how the scaling of the times are, or how the scaling of the infrastructure is, then you're not going to be able to implement that in the factory. So being connected, safe and secure, obviously it's pretty obvious. You need to be able to provide that security, not just at the network level as communication, but also being able to go to the machine. So the machine itself, if I come in, I'm a bad actor, and I go to the machine and I start pressing buttons that I'm not supposed to press, there should be some safety awareness in the machine to tell you, okay, I'm not supposed to be pressing this button, something's going on. And manage data. So obviously, once you get the data, it's not, a lot of the times they said that 40% of data that's coming out of this IoT world will be from the factory by 2020. So that's a lot of data. So unless you know what to do with every single data point and every single sensor that you're reading, then it's just not, there's no relevance. It's just data. So you want to make sure that you understand what that data is, understand how to use the data, and where to use the data in whatever control level. So if you look at a plant floor, there's like 3 main levels. The enterprise level, as you know, that's the main office. The control level, and the field level. So within these levels, there are different elements. So first is what I talked about was the networking side, the connected part. So the lower you go into the network, the more important is real-time. Real-time is more important in that regard. So again, like I mentioned, you have to be able to understand that there should be this seamless connection between what you have in the plant and all the way down to the enterprise level. Another piece I mentioned about safety. So as you go lower into your control level, safety is becoming, safety of course is number one. And I'll show you a little bit of example of what we have for safety. Network, as you go up the level, obviously network security is going to be more important. So you as a provider, as a system integrator or something, that you need to understand, what are the pieces that you have, what can you contribute either from a safety perspective or in the network security perspective. We talk about 2 different clouds, 2 different fogs, right? We talk about the big cloud, but there's also something called fog data. So fog data is more about the M2M part of it. That the machines between machine A, B, and C can communicate. They'll be able to exchange data. They can do some sensor fusion. They can be able to provide just enough context within the machines so that they can provide some first level of analytics, first level of connections and operations. And I drew this simple one about analytics. I'm just saying that every stage in the plant has to have a different type of analytics. It's not about the cloud. That's not enough. Doing analytics in the cloud is not enough. Doing analytics at the control level is not enough. You have the ability now, our processors, our solutions, our SOCs are smart enough to do a lot more than just doing it at the enterprise level. So you want to take advantage of that. You want to understand from your customers, at what level they want their analytics at. And finally, access. So for access, it's really, like I said, the cell phone is not the main thing. Access means that, are you giving it to the right people? Are you giving it to the right devices and solutions? You want to also give it access to people that are not normally in the factory. So maybe some of your partners who are doing just security, or you want them to understand the security patterns, just that piece of it. So you want to give access to a different set of individuals, not just within the factory, but even to maybe even the machine builders or whatnot. So my story is just to say that, well, the IIoT is great. There's a lot of different opportunities, but in any IIoT solution, we always start at the edge. And my definition of edge is below the control gateway. So okay, safety first. In anything that the factory does, they're never going to change anything unless you've solved their safety concerns. So you've seen this story, right? Another Volkswagen just killed another accident. So in a German factory, one of their robots actually killed a person. So it could get worse, right? Once there's a breach of safety in a factory, you can kill many people. Rather than you got your Fitbit, your heart monitor didn't work, one guy died. Okay, that's bad, but in the factory, of course, it's very critical. So safety is priority one for any factory. They say, OSHA said that $60 billion of productivity is lost just because of safety concerns or safety issues. Obviously, if you're familiar with IEC 61508, those are your SIL 2, SIL 3 standards for your industrial control systems and your machines. Those are going to be very important. If you want to sell anything to Europe, then you want to make sure that it is SIL 2, SIL 3 rated. And there's different strategies on that. So the problem is that the cost burden for functional safety, you need these PhDs or scientists doing safety to statistical modeling just to understand what functional safety is. So the problem is that this cost burden and the expertise within the plant is just not there. So what we've done at Renesas is actually provide a complete solution that is already SIL 2, SIL 3 certified. If you can imagine, a lot of the MCU suppliers, have to prove that their MCU core itself it doesn't inherently fail in different modes. So the idea is that the more you provide robust testing and fault injection into the MCU, and you're able to prove to TÜV or any of the safety compliance guys that yes, it's inherently safe, then that's where you can get your certification. So what we did was, instead of you as an end user to have to do the whole thing, we've already provided that software solution. So we have a software self-test code that's already SIL rated for 2 and 3. So what did we do? Let me just tell you. So we did 39 test segments. We went to a safety controller company, and we asked them, how many test segments do you do? And they said 5. We did 39. So I think we're pretty good. So we made a very comprehensive test program, high quality, and the safety manual to go with it as well. We put 190,000 fault injection tests. Because we know what our chip does and how it works, we were the best people to know how to try to make it fail. So we have a 90% diagnostic coverage. Is a very high number, even for TÜV standards. From a documentation perspective, a lot of our customers are thinking, okay, if I'm going to implement functional safety, the amount of documentation I need is really, really thick. So we've already provided the documentation that's already pre-approved by TÜV. So we provide you the fit data, we provide you all the test segments and how those correlate to the tests that we did. So this is definitely going to save you a lot of time. The other good thing is that because we tested it on a single core, if you're familiar with the RX, then we have that already done for all of the RX cores. So if you're using a RX 600, RX 200, RX 100, we have that software solution that is available for you. The Synergy, of course, is a brand new product. And if you're doing functional safety, you do know that you need either 1 year of mass production or 1 million pieces out in the field. So obviously, we're not there yet. So, but at least the pieces that we have in place for Synergy is there to provide the functional safety program. It's actually, functional safety is going to be part of our product plan for Synergy. Okay, let's go into IoT networking. So, talking about the connectivity side of it, and I mentioned about the different time domains, right? So in the different time domains, you'll see different protocols, being able to, having to support Modbus or HART or CANopen, having to support EtherCAT for the real-time stuff, or Profinet IRT, or having to support Ethernet IP from the process level, and then having that ability to connect to OPC servers that are out there from an infrastructure perspective. So all of these different protocols, all of these different communication time domains have to work seamlessly. So it's going to be a very important thing. You'll have to figure out which portion of you can contribute in this realm. But the point is that we want to make sure that we give you a platform and different solutions that could cater to all of the different industrial protocols. So we have something called the RIN32, so RIN, and it is a multi-protocol support SoC. So it has a Cortex-M3 running at 100 megahertz. It has some hardware accelerators that allow you to improve your networking performance. It also has a hardware RTOS that's also built in, that's specifically designed to improve your network throughput. The Synergy and the RX devices, they do have dual Ethernet, and I'll show you a little bit about what that is from a block perspective. But they do support the soft protocols like Ethernet IP or Modbus TCP fairly easily. It's a dual port chip, so you could do daisy chaining, you could do store and forward, you could do cut through as well. We also have the TPS1. This is the Profinet IRT. So if you're familiar with Profinet, there's a device or an ASIC that they have called the isochronous real-time chip. And we actually made that for Siemens, so we have a general purpose solution that's available. From a sensor perspective, we do have a IO-Link master. So IO-Link is driven out of Siemens, driven out of Balluff, and these other industrial companies. And we have that solution as well. It's a single chip with a 16-bit MCU and a IO-Link master chip as well. So I guess what I wanted to show you is that we do have a comprehensive set of solutions, devices, software, partners that will be able to provide you this support for the industrial networking protocols. So just a quick detail of what the RIN32 is, just to give you a reference. So two major pieces that I wanted to highlight is the hardware RTOS. So the hardware RTOS is one of those accelerators, is a unique IP that we have that improves the prioritization, rather than just doing it in software as a software RTOS. So you can bolt over, let's say, a Micrium micro COS wrapper. We'll use the same system calls as you would, but it'll be the whole engine for prioritization and task management is actually done in hardware. So it helps to improve your performance from your networking. The other piece I wanted to mention is that the chip already has PHY in it as well. So the PHY is already inside the chip. It'll reduce your costs. So this is just a diagram about what the hardware RTOS is, what it does compared to task. Typical RTOS has task scheduling, the prioritization done in software, and then you have to do an interrupt to the CPU. Because you're doing it in hardware, you don't have to bother the CPU on that operation. Of course, the task switching still has to be done by the CPU, but at least you've gotten some of the prioritization and task scheduling already done at the hardware level. So it's definitely a big advantage. And there's also an Ethernet accelerator as well. So it does the buffer management, it does the some of the checksums already in hardware, so that if you're streaming data very quickly, it actually does it in hardware as well, and it helps the TCP/IP stack. So together with the hardware RTOS and the Ethernet accelerator, you can improve your throughput by up to 5 times faster. So it's a fairly good device. Obviously, Synergy S7 has a dual Ethernet as well. If you take a look at the EtherCAT, this is the EPTP block. This is the 1588 block, so we can support 2 channels. It can support 1588 version 2 for PTP. It can support ordinary clock, boundary clocks. There's different scanning modes that are available as well. So if you are interested in this for the just general purpose time stamping of your network, this is also available. So let's move on to security in industrial IoT, both from the connectivity's perspective as well as the device level. So I don't know if you're familiar with this guy. So this is called Norse Corp. If you go to this website, you'll see that there's a real-time attacks from all these different countries to the U.S. and U.S. attacking different countries. It's real time. It's pretty cool. And so you'll see a lot of people want to attack Microsoft, I guess, and a lot of people from the Bay Area. So, but our nice friends from China and Russia and Eastern Europe are attacking each other. So these are just activities on cyber attacks that you'll see. And the more you see it, it's happening like 3 seconds. I think 10 attacks are happening every second or so. It's really interesting. So it just gives you context that the security part on your cybersecurity is a very, very key component to any kind of IoT solution. Maybe you're familiar with this. I think it was just last year, a German steel plant was hacked, and the steel plant, I guess the kiln was over temperatured, and it kept on going. The control system said, yeah, it's safe, nothing's happening, but the actual kiln kept on going, and it actually had pretty much 2/3 of the plant explode because of that. So it was just done by one individual, just hacking into the system, doing some spear phishing, and these guys do it randomly, so they don't care. They're just going to do it for the sake of doing it. When you talk to an FBI guy who's doing cybersecurity, he's going to say that nation states actually have teams of just hackers to just try to see what they can access. So you can just imagine, some of our friends in the Eastern Europe as well as in Southeast Asia that will be doing this. So you have to make sure that we have context for that. So when you look at the security levels and security awareness, typically you'd want to take a look. They're all different in different levels. When you go into the access control, that's the one where you walk into the PLC, you're making changes to the settings and things like that. That itself has to have intelligence. You can't just walk into a PLC, change the settings, and not think that somebody's trying to, it's a bad actor trying to hack into the system or trying to manipulate the operation. So that's going to be very important for you to do. As you go further away, you have to figure out that it has to be, you have to understand threat awareness. So for example, if you were in a plant and some guy's walking in the street on the backside of your operation and he's not supposed to be there, your security solution should understand that that guy's not supposed to be there at that time. So it becomes much more complex. It becomes much more intelligent. So if you look at the different solutions around the security, obviously you've got secure key management. You want to be able to do some remote download and remote firmware update, those types of things. But at the same time, you want to also control some of that access. The other thing is the data itself. You can have spurious data coming into your control systems where you can kind of hack the data coming into from the sensors to your control, saying, yeah, you know what, let's add another 0 here. Let's add another 1 here, and then we'll see how that's going to affect the plant. So I think one of the big stories, the Stuxnet story, is all about that. They're having this 1-bit change in the network for the control systems, and it just it had very big consequences for that nuclear fusion plant. As you go further out, then of course the security analytics become more important. So what we looked at from our perspective is to understand what are the different solutions that we can, figure out from the device level. So we looked at both the networking security and communication, as well as the device security. So these are just some of those objectives of a security solution. You need to be able to protect from the cyber attack, but also the intrusion detection, understanding that the packets that you're receiving is valid, understanding that the sensor data that you're receiving is what you're expecting or within range, and that there's no bad actors in every level of your factory. So we work with a company called Skynet, and they have a solution. So typical industrial control system is that you open up a VPN, and you open the door. Once you open the door, you can connect to it. You can see the plant. You can see the operation from the cloud, right? The problem is once you open that VPN, other actors can go in and start taking a look at that data as well. You'll see the full plant because the communication out of the plant is the full plant. You're going to be able to see the image of the full plant. And that's been the traditional way of sending data from the plant to the cloud. Skynet's solution is a little bit different. They actually have an embedded agent. So embedded agent on the embedded device itself. So right now they have it on the Synergy S7. And it'll work with the S5 because it has the Ethernet connection as well. So they put that ETK, what they call ETK, inside the device. It initiates the communication to the server. So it's not, you don't have access to the device going in and saying, yeah, can I go into you? No, it's the machine itself, it's the device, embedded device saying, you know what, I've got data to send out to the cloud. So they have a SkyHub solution, and this solution will provide a local connection, so you could do M2M locally within SkyHub, as well as something that you can connect out to the virtual, the cloud. So what happens is that these agents, these web clients, they're able to get the data. Once you have it bidirectional, there's no inbound traffic that goes in. It's all outbound. But on the other hand, once you get that connection initiated by the device, then everything can now be bidirectional. There's no open VPNs. There's no open attack surface for the plant itself. The other thing is that they have very fast data throughput. So if you look at the plant, normally you want to be able to access the data, understand what's happening in your sensors in the data points. We have latencies of milliseconds. So this one is just an example, 50,000 data points a second. So if you went to our demo in the station in one of the shows, in our show, you saw that how fast the reaction time is of the dials that you're pressing and you're adjusting. So it's a very robust solution. They also have a real-time HMI in plant with 4,000 libraries in a simple SAS model. So they can work with any of the suppliers like yourselves. Instead of reinventing what your cloud is, they already have that solution. It's already secure. It's already designed for industrial. It's already designed deployed in other application spaces. And of course, you could take advantage of it as your infrastructure. You still have to add your analytics. You still have to add your intelligence. You still can design the policies that you want relative to how the operation works. So that's your value add anyway. So our idea was if we can get our Synergy device with that capability, then that's a platform that you can use. The other thing is we took a look at the security from the device perspective. So obviously there's a lot of different classes that you have for security around secure boot, being able to make sure you want to change your firmware and to do any kind of counterfeiting or any kind of fake production or those types of things. What we were looking at is a little bit more from the industrial perspective is to understand the connectivity side of things. So we wanted to come up with a solution, and we worked with a company called Icon Labs, and they provide this security framework solution. There are different modules that they provide that they can do the authentication. They can provide the intrusion detection. They can sniff the packets that are coming in. the solution can provide, the anti-tamper going into the machine itself, going to the device. They also, these are also ISA 62443 compliant, so they're easy to hook into a McAfee security management system solution as well. So again, these are like these scalable solutions that are available. We just launched it this week. Obviously, the guys from Skynet and Icon Labs are here today if you had any further questions. But we wanted to use this as a starting point. For example, the Icon Labs security solution works for both the Synergy platform as well as the Win32 platform. So you want to leverage from that as well and use that as your value add to what you want to provide. Obviously, Synergy has a lot of different security in hardware. I'm sure you've gone through several classes here in security, so I'm not going to delve into it. But certainly, you want to take advantage of all the hardware accelerators, the true random number generator, all the crypto engines that we've got from the Synergy perspective to leverage for your application. I know there was different specific classes just for security. Okay, so let's talk a little bit about analytics. It's just a couple of slides. I know we're kind of tight on time. The analytics is such a big topic. So what I did was kind of just steal the IIC analytics infrastructure reference architecture. So this is the concept from the IIC consortia. It's for, you can get it off the web as well. But what they're trying to say is that there's different domains: the control domain, the information domain, operations, and business. And within each of these domains, there's different kinds of analytics you can do, as I mentioned. So, for example, in the control domain, you could do descriptive analytics. What is the temperature of my motor? Is the inverter gonna blow up, anytime soon? Is my, is the belt on my machine kind of, making a sound or something? It's squeaking a little bit more. Is my throughput going down? Is the quality of the machine going down? So all of these are all descriptive analytics. From the information analytics, then you can do a little bit more predictive. So you could do that digital twin that I mentioned. So you could do some predictive analytics, saying, what if I did this model? How is that going to affect the operation? So you can start doing that kind of analytics. On the operations domain, you have these prescriptive analysis, which means that now that you have the data, you as a plant manager can start tweaking things on your own because of your experience, because of what you can do from the plant side. So if you're able to do that kind of analysis on your own at the plant level, then it's more than just the scenarios that you have. And of course, at the end, is the decisive analytics. Let's say that machine is really not doing anything. I'm going to kill it. It's not giving me the ROI, that whole business unit. I'm just going to kill that one. Or we should pump it up, make it more efficient. So those are different kinds of analytics that you can do just from networking. Then I talk about, or I'm showing here different kinds of databases, right? So it's where to find those data. How do you leverage that kind of data? So all those modeling of data are all driven out of the IT guys. So unfortunately, I'm not an IT guy, so I'm just going to leave you with the image. And of course, the slides. So one of the one of the things that I'd like to mention, of course, is that Renesas has a full range of devices that have really good analog in the device. We've got some RX devices that have a 24-bit sigma delta, so it's usually used for flow control or any kind of flow and movement, gas sensing, those types of things. We've got other SAR ADCs. We've got a 12-bit SAR. We actually have 14-bit SAR. The Synergy devices, the S1, S3, they're designed really for a lot of the different smaller sensors. That has this one has a 14-bit SAR. The S5, S7 has 12-bit SAR. So we're constantly looking at improving our analog functionality within the MCU, so that you have a lot of choices if you wanted to do that. The other thing is that because these have enough smarts, you can provide a little bit of a small AI, right? Artificial intelligence just within each device. You could do some sensor fusion. You have enough processing power to do that. Some devices have floating points. Some of them have other blocks that you can use for your sensing. So the message is that we do have a portfolio of MCUs that are rated for industrial up to 105 degrees C. It has the analog part of it that provides you that good reading. So you can take advantage of that in any kind of analytics that you want to do. This is a block that is something called the event link controller. It's something unique. It's hidden in the manuals, but I really like it because it from a sensing perspective, it's actually a hard block that allows you to do some direct interaction without bothering the CPU. So, for example, if you send something out of your ADC, it turns on the timer, turns on the ADCs, it does the reading, just to turn on the subsystems of the MCU. And that way it helps your RTOS, it helps your operation, it improves the performance, it lowers the power that you're using. Because obviously reading out from a remote terminal unit, you need to be very efficient in reading as much as you can. So if you have a chance, look at this block, event link controller, and see if you can take advantage of that in your reading of analytics. Okay, so let's talk a little bit about the business opportunities. So here's just a kind of a topology of different suppliers, right, from the silicon all the way down to the enterprise supplier. And as I mentioned earlier, one of the big things about IIoT is this opportunity for new business, new profits and stuff. So you'll see that the industrial OEMs are now moving up to the system. They're providing the cloud, they're providing the platforms for you to do analytics. They're providing you they're working with the SAPs of the world and the Oracles and things like that to provide more of the software infrastructure. So they're partnering with them. So you see that more often. For us, the silicon vendors, we're going up as well. As you saw from Synergy, the whole story is that we're not just providing you silicon, we're providing you a complete platform with the solutions, with the RTOS, with the TCP/IP stack, all of these firmware pieces that you have. With the combination of our VSA partners like Icon Labs and Skynet, we're able to provide even more value add to the platform and be able to make you enable you guys to come up with a much more intelligent solution. So that's sort of one of the patterns. These integrators and the embedded hardware software guys, maybe a lot of you are here. One of the opportunities would be the analytics. So because you're your own experts within your fields or within your technologies or solutions, you want to be able to add that value add, their core competence as part of your solution. It's not about just doing the cloud component of it. It's being able to add some of that intelligence. So that's the value add that you can provide. On the other hand, the guys who are doing the IBMs and the Ciscos and some of the enterprise services guys, they're looking at better cloud security. So they want to say, I'm going to manage your key storage for your device. I'm going to put that security in. I'm going to be able to provide a robust network connection between the enterprise network and yours. So they're the IT guys, right? So they're the ones who are trying to understand what the OT guys need, and they're trying to link to it. So based on all of that, I mean, there's a lot of opportunities for, and this is how the kind of the vectors in of business opportunities of these different players. So if you're in one of these guys, obviously you guys are in one of these blocks, then you kind of have a good understanding of where the other players are trying to trend, whether you're intersecting or whether you can complement what they're trying to do. Okay, so we talked. So just to give you a summary about what revenue opportunities, I know there's a lot of them, but I wanted to summarize and kind of end with this one, is that you want to start at the edge. You have the capability. You're here in a Renesas forum because you understand what a microcontroller can do. You understand how you want to leverage your microcontroller in the intelligence to provide that connection, to provide that cloud connection, the intelligence that you want. So start at the edge. Take a look at safety. Take a look at the network protocols. Take a look at this kind of a control layer analytics. Those are things that you want to look at. Now, if you want to be in the IT OT management, then that's obviously a bigger task, right? So you're gonna have to go against the Oracles and the SAPs and those types of guys. But the point that I wanted to make as well is this data as an asset. So data as an asset is a very interesting concept because the data that you're receiving from your controller, from your machine, or from your system, you can actually start using that to leverage to different companies. So let's just say if you're not getting, it's not the pure data that you're getting the intelligent data, you're getting the collected, kind of synthesized data, then that's the one you can share with other customers that you want, right? You want to leverage that. How do you monetize that? So having data as an asset is a new model that's coming up quickly. So the enhancement services, we talked about a little bit, in different forms. Obviously, being able to provide a preventive maintenance. You can provide a little cloud within the different machines that you've got. You don't need to go to the cloud right away. Right away. You can just have a little fog between your machines or your devices and provide that value as well. Because the plant itself, they're going to have a lot of infrastructure already. They're the guys talking to the GEs and the Siemens and the Rockwells. What you want to provide is something that you can plop into the plant without bothering it, without being able to, just tell the whole plant to change its infrastructure. But also be able to provide a little bit of intelligence based on what your value add is, based on your what you want. Another thing is, of course, visualization. So if you're able to do the rendering, if you want that as part of a business model, that's also a legitimate business model. You can use that one as well. Okay, so just as a summary, I mentioned that the industrial IoT is different from general IoT. It will reshape the new manufacturing. The Siemens guys are really gung-ho. The GE just launched this Predix, and they're looking for a lot of partners. So that might also be an opportunity. They're reshaping the manufacturing of the future. Obviously, you have to consider security and safety at every level. You want to see if you can provide intelligent sensors and digital devices. And obviously, because you're here in our session, try to start from the edge. Take a look at what are the opportunities at the edge that you can do. It doesn't have to be this vertical cloud connection. There's other opportunities on the horizontal plane from either connection or security or other added value. Any other questions? Yes. The Skynet, the solution is fully encrypted. Yes, it is fully encrypted, yes. So it's SSL. Yeah. All right. So any other questions? I think we're zero time. So well, thank you very much for coming. Hopefully you got some good information.